In this tutorial, we will try to model flin-flon copper and zinc mining in Canada. You can find the data for this tutorial and links to the original data below this video. This is our main page. You can go back here clicking Geomodelr in the top left corner. This page contains the studies you own, have been shared with you, and some public studies. We will start by giving a name to the geological study and a short description. The name and description will be used by Geomodelr to create a preview of our model in the map. By creating public studies, you can share your knowledge with humankind. By creating private studies, you and your company can securely create and share information. After creating the study, we can enter to the study page by clicking it. You can think of the study page as the control room for your model. In the middle of the page, we see that we need to set up our model. More options will be shown to us when we do it. Permissions are at the bottom of this page. You are administrator and humankind is a viewer. Let's open the form. In the left, we can see each role that can be applied. In the right, we can see some users. Start typing a username to add him. Contributors can do almost anything in the study except changing permissions or removing studies. Viewers can only view, and reviewers can modify articles. Let's move to the right to the files repository. The files repository can be used to upload our information and manage it. We can use shapefiles for maps and geotiffs for topographies. Let's find a file with our geological map and faults. The shapefile needs to be zipped with all its auxiliary files. Let's wait a few seconds for the file to upload. After uploading Geomodelr, we'll extract its metadata. Geomodelr shows proc when something is processing. After extracting the metadata, the type of the file would be a zipped shapefile. Click to explore the contents of that file, faults.shp and map.shp. The Operate with Files page, also known as the repository page, contains operation to work with files. You can click the button or click the icon at the top right of your study. It will have links for this and other pages. The repository page contains operations to create image layers from geotiff files or images, and also to fix digital elevation models. The most important operation here is to georeference an image, to use it as a layer. Let's go back to our study page. In the Navigate button in the top left, let's click first link to the study page. Back in the study page, we are going to set up our 3D geological model. We first need to provide a digital elevation model for our study. It will delimit the top of the model and will allow us to create cross-sections and visualizations. If you don't have a digital elevation model, Geomodelr can download and produce one for you. For this, Geomodelr will use SRTM data. SRTM data should have a precision of about 30 meters. The model needs also a geological map with units and faults. We will select the map file and the property that will be reflected as unit. This property will be interpolated. We will also select as many other properties as we want imported. We can optionally import faults. In this case, we need to import a file with line strings. We also select the name of the faults and as many properties as we want. Having selected files make georeferencing easier because they already have a coordinate system and a bounding box. It's recommended that the coordinate system is projected or you will have problems. Let's close up to the region that we want to model. The files we used previously can be seen here. To narrow the region, we need to select I'll georeference it manually. We'll copy the coordinate system inferred from the files. We will paste the coordinate system in the box that appeared. We also need to select the bounding box of the region we are modeling. Clicking in two corners of the bounding box will select the region. It will use the coordinate system shown in the coordinate system box. You can also use the search to find a coordinate system. More than 3,600 coordinate systems are available. We can search for a coordinate system by searching for a text that refers to it. For example, Canada. We narrow down the search by selecting projected. It's very important that our coordinate system is projected. Selecting a coordinate system will change the current one, so we just close the selector. Finally, clicking Create Model will set up the model. We will have to wait a few seconds until all our files are processed and the topography downloaded and set up. Processing this map takes a few seconds, as it's very large with thousands of polygons. The topology of the map will be correct after it ends, and we can begin to create cross-sections. Let's click our map. We will enter to our geology editor. We can see that Geomodelr assigned the color to each of our units automatically. The red circles are the nodes. We will use them later. We will review nodes when we are drawing the map and cross-sections. Let's go back to the study page to continue browsing our model. Let's create our first cross-section. First, we need to write a name for it. We'll use create an empty or interpolated cross-section. The first cross-section will determine the direction of the rest of the cross-section in the interpolation. We pick the line where the cross-section will be drawn. We can pick it from the map or fill it manually in the boxes above the map. We will also have to input the lowest coordinate of the cross-section. Click Submit to create it. After waiting a few seconds, we can see our first cross-section. Let's upload boreholes as Microsoft Excel file. The format that can be found in the links of this the format can be found in the links of this video. To create a boreholes dataset, we will need a colors file, a surveys files, and an intervals files. All the files can be together in a single Excel with different sheets. We'll wait a few seconds for the file to upload and process the metadata. We can browse all of the sheets of the file. It contains colors, surveys, and several possible intervals. Let's click in New Dataset. We have to enter a name and select that we will create a boreholes dataset. The first sheet we have to search is the color. We select it from the list. We have to select the borehole ID and X, Y, and Z coordinates. Required fields are shown in red. Clicking the fields that appear on the right will allow you to rename them. Remain whole as D as ID. We also need UTM-X to be renamed as X, UTM-Y to be renamed as Y, and CFIN to be renamed as C. A survey is also necessary. The survey needs the ID of the color, the distance, the dip, and azimuth. Rename as needed. Finally, we need to specify the interval. We will need a value for from and for to, and the same idea as in color and survey. We will also specify the properties we want to import from the intervals. The formation property needs to be renamed as unit to take the same color than the map. Finally, we will add as many other properties as we want. Let's submit to create our boreholes dataset. We will wait a few seconds until the stratigraphy dataset is ready. With boreholes, we will draw cross sections and visualize them in 3 dimensions. We can see it contains 2537 boreholes, and we can check the properties we loaded in them. Let's open the visualizations page. There's a default visualizations available. It contains the map and the cross sections we just made. Let's go back to our study. Let's then click the articles page. The articles page contains the abstract with the title of the study, the description, and the visualization we saw previously. The abstract will allow other people to search and take interest in your geological models. We are coming back here to change our abstract later. For now, we'll go back to our study page. We will finish the first part of this tutorial by saving a version of our model. We just needed to give it a name, and that's it. Model versions can be used to go back to a previous state in our model, but also to download and use it in the query tool.